Good morning, my dear Prep 1 students. Hope you're all fine today. In today's lesson, we are going to take the second lesson in Unit 1, which is comparing and ordering rational numbers. What's comparing and ordering rational numbers? It's the same as comparing and ordering fractions. But before we go, let's first remember that each number on the number line has an opposite. So for example, when we were talking in integers, we know that the inverse or the opposite of -4 is 4, and that the opposite of -2 is 2. What about if I want to find the opposite of 6? It's going to be -6. So each integer has an opposite to it, exactly the same number but with an opposite sign. What about rational numbers? Does rational numbers also have opposites? Let's go and see. Here is the number line for the rational numbers. For example, if I want to find the opposite of -1/4, it's going to be the same number but with an opposite sign, and it's 1/4. What about if I want to find the inverse of 2/4? It's going to be the same number but with a negative sign, and it's going to be -2/4. Let's go now to page 4 in our school book, exercise 1. I would like you all to write today's date beside of question number 1, and let's begin. Use the number line to identify the opposite of each rational number in the table. And he gives me here an example that the opposite of half is -half. Let's begin now with 3/2. 3/2 is a positive number, so its opposite is going to be the same number but in negative. -3/2. What about 4/2? 4/2 is a positive number. Its opposite is going to be a negative number and the same number, -4/2. And remember that -4/2 is equals to -2. Let's go now for -5/2. -5/2 is a negative number. Then its opposite is the same number but positive, which is 5/2. 7/2 is a positive number, so its inverse is going to be the same number but negative, -7/2. Let's go now for -3/2. A negative number, its opposite is the same but positive. So the opposite of -3/2 is 3/2. I would like you to pause the video and go now complete the last 4 questions and then come back. -7/2, it's a negative number. The opposite is the same number but positive, which is 7/2. What about 2/2? 2/2 is a positive number. So its opposite is the same number but negative, -2/2. And don't forget that -2/2 is equals to -1. -6/2 is a negative number. The opposite is a positive number, and it's the same number, which is 6/2. And also 6/2 is equal to 3. Let's go now for 6/2. 6/2 is a positive number. Its inverse is going to be a negative number, so -6/2, which is equals to -3. I would like you to pause the video and go and copy question number 1 in your school book, and then come back to complete. The question now is, how can I plot a rational number on a number line? We know that a number line consists of integers, but how many rational numbers is there between each 2 integers? There is an infinite number of rational numbers between any 2 integers. For example, I know here that 0 is 0/8, since here I have a denominator of 8. And we know that 1 is also 8/8. How many rational numbers is there between 0/8 and 8/8? We are going to have 7 rational numbers. 1/8, 2/8, 3/8, 4/8, 5/8, until I reach 8/8. I will have 7. What about if my denominator was 6? Then I'm going to let the integer with the denominator of 6. 0 over 6 for 0 and 6 over 6 for 1. How many rational numbers is going to be now between 0 and 1? There are going to be 5 rational numbers, starting from 1 over 6, 2 over 6, 3 over 6, 4 over 6, and 5 over 6. So, the most important thing to determine how many rational numbers is there between two integers is to see what is my denominator. According to my denominator, I will have minus 1 of this denominator between each two rational numbers. For example, I have here my denominator 4. So I am going to have 3 rational numbers between any two integers. Let's go now to school book, page 4, question number 2. Write today's date beside question number 2. Complete the rational numbers on the number line. The most important thing to be able to plot a rational number on the number line is to see what's my denominator and let all my integers with the same denominator. So here I want to make this negative 2 a rational number having a denominator of 3. Negative 1 a rational number having a denominator of 3. 0 a rational number having a denominator of 3. And the same goes for 1 and goes for 2. I know that 0 is 0 over 3. 1 is 3 over 3. What about 2? 2 is 6 over 3. And if you don't know from where did this 6 came from, just go and multiply your integer with the denominator and you will get the numerator, which is 6. Let's go now to the negative side. Negative 1 is equals to negative 3 over 3. And negative 2 is equals to negative 6 over 3. And again, if you don't know how to bring this negative 6, just multiply the negative 2 by the denominator, which is 3, and you will get the negative 6. Let's go now and see what are the rational numbers which are missing. Here I have 0 over 3, so the next rational number is going to be 1 over 3. Then I have the rational number 2 over 3, and then 3 over 3, and then going to be my next rational number, which is 4 over 3. Let's go now for the negative side. I have 0 over 3, negative 1 over 3, so the next rational number is negative 2 over 3. And then I will have negative 3 over 3, negative 4 over 3. The missing one is negative 5 over 3. Let's go now for number B. In number B, I have my rational numbers with the denominator of 4. So we are going to let all our integers with the denominator of 4. 0 is 0 over 4. 1 is 4 over 4, and negative 1 is negative 4 over 4. Let's go now and see our missing numbers. 0 over 4, 1 over 4, then the missing one is 2 over 4. 3 over 4, 4 over 4, then I have 5 over 4, and then 6 over 4. Let's go now to the negative direction. 0 over 4, then I'm going to have negative 1 over 4. Negative 2 over 4, the next one is negative 3 over 4. And then I will have negative 4 over 4. The last missing rational number is negative 5 over 4. I would like you to pause the video and go and copy this number line in question number 2 in your school book and then come back to complete. Let's go now to page 5, question number 3. He wants me to represent each of the following rational numbers on the number line. To represent a rational number on a number line, I must first know where does this rational number lie between which two integers. And then I'm going to see what's my denominator to determine how many rational number is there between each two integers. So let's now begin with number A. Number A is 1 over 3. 1 over 3 is a proper fraction, so it's less than 1, meaning that it lies between 0 and 1. So let's draw now our number line. Here is the number line, and I am going to make it from 0 to 1. What's my denominator? My denominator is 3, meaning that I have two rational numbers between those two integers. I know that 0 is 0 over 3, and 1 is 3 over 3. So I have here 1 over 3 and 2 over 3. And here is exactly the rational number that he's looking for, 1 over 3. Let's go now for number B. Number B is negative 1 over 3. Negative 1 over 3 is the inverse of 1 over 3. So sure, it's going to lie between 0 and negative 1. We are going to begin from 0 on the right hand side and negative 1 on the left hand side. My denominator is 3. So the number of rational numbers between two integers is less than 3 by 1. So they are two rational numbers. I know that 0 is 0 over 3 and negative 1 is negative 3 over 3. So the rational numbers in between are negative 1 over 3 and negative 2 over 3. And here is the rational number that he's looking for, negative 1 over 3. Let's go now for number C. Number C is negative 4 over 5. And again, negative 4 over 5 is a proper fraction, so sure it lies between 0 and negative 1. Again, here is my number line, and I will put the 0 on the right hand side and the negative 1 on the left hand side. I have my denominator as 5. So the number of rational numbers between 0 and negative 1 is less than 5 by 1. So they are 4. 1, 2, 3, and 4. I know that 0 is 0 over 5. Negative 1 is negative 5 over 5. The rational numbers here in between are negative 1 over 5, negative 2 over 5, negative 3 over 5, and negative 4 over 5. I am looking for negative 4 over 5. So here is the rational number which I am looking for. Let's begin now with number D. Number D is negative 3 and half. Negative 3 and a half is a mixed number. So let's first go and change it to an improper fraction. The negative sign is the same and my denominator is the same. Then I'm going to make 2 times 3, which is 6, and then add 1, so it's negative 7 over 2. I will look at my denominator. My denominator here is 2. So there is only one rational number. Negative 3 is equals to negative 6 over 2. And what about negative 4? Negative 4 is negative 8 over 2. So the only rational number left is negative 7 over 2. And this is the number he's looking for. Let's go now for the last one, which is number E. Number E, 1 over 5. 1 over 5 is a mixed number. Change it to an improper fraction by having the 5 in the denominator as it is. Then 5 times 1 is 5. I am going to add 1. It's 6 over 5. And it's quite clear that 1 over 5 lies between 1 and 2. Here is my number line. It's going to be from 1 until 2. As you can see here, my denominator is 5. So I am going to have 4 rational numbers between 1 and 2. 1, 2, 3, and 4. 2 is equals to 10 over 5. 1 is equals to 5 over 5. So the rational numbers between them is 6 over 5, 7 over 5, 8 over 5, and 9 over 5. And here is the rational number he's looking for, which is 6 over 5, 1 over 5. Let's go now and see how to compare between rational numbers. Comparing between rational numbers is the same as comparing between fractions. So for example, if I have 5 over 11 and 7 over 11, both of them have the same denominator. So the greatest numerator is the greatest fraction. 5 over 11 is less than 7 over 11. What about if I have two fractions having the same numerator? Here we call it a crazy fraction. Why it's a crazy fraction? Because simply the one with the smallest numerator is the one which is greatest. So 5 over 3 is greater than 5 over 4. What about if my two numerators are equal and are in negative? Negative 5 over 3 and negative 5 over 4. Which one of them is greater? Simply, the one with the greatest denominator is going to be greatest. Sometimes we have two fractions or two rational numbers with different numerators and different denominators. In this case, we go and do cross multiplication. 5 times 9 is equals to 45 and 6 times 4 is equals to 24. Which is greater, 45 or 24? Sure, 45 is greater, so 5 over 6 is greater than 4 over 9. Let's have another example. Negative 4 over 5 and negative 5 over 8. We have different numerators and different denominators. So we are going to do cross multiplication. 8 times negative 4 is negative 32, and 5 times negative 5 is negative 25. Negative 32 or negative 25 is greater. In negative, the smallest one is the greatest, so negative 5 over 8 is greater than negative 4 over 5. Did you see how much it's easy? It's just like comparing fractions. Let's go and have some important remarks now. If the two numbers have different signs, then the positive number is greater than the negative number. So for example, if I have 0.05, sure it's greater from any negative number, even if this negative number was a negative rational number. Any positive rational number is greater than any negative rational number and also is greater than 0. So for example, if I have 4 over 7, 4 over 7 is a positive rational number. Sure, it's greater than any negative rational number, which here in my example is negative 15 over 2. And also, 4 over 7 is a positive rational number, so it's sure greater than 0. Our last remark is, any negative rational number is smaller than any positive rational number and is also smaller than 0. So for example, negative 5 over 7 is a negative rational number. Sure, it's smaller than a positive rational number, which is 15 over 2. And at the same time, it's smaller than 0 as well. Let's go now and solve some examples on comparing rational numbers. I would like you all now to go and open your school book page 8 and write today's date. Right beside question number 1 classwork. Here are some rational numbers and we want to compare between them. So let's go for number A. Number A is negative half and 0. We said that any negative rational number must be less than 0. So negative half is less than 0. Let's go now for number B. Negative 3 over 4 and quarter. Here I have a negative rational number and a positive rational number. And we said that any positive rational number is greater than any negative rational number. So negative 3 over 4 is less than quarter. Going now for number C. Negative 4.5 and negative 5. If we are going to have a look here on the number line, I will have here negative 4 and I will have here negative 5. And here is negative 4.5 or negative 4.5. So sure, negative 4.5 is greater than the negative 5. Going now to number D, 4.5 and 5. Let's draw again the number line. If I have here the 4, and here is the 5. 4.5 is in between 4 and 5. So sure, 5 is greater than 4.5. Number E, every positive rational number and 0. We said that any positive rational number is sure greater than 0. And in number F, every negative rational number, we know that a negative rational number is always less than 0. Let's go now for number G. Number G, absolute value of negative 3 over 2.5. We know that the absolute value of any negative number is the same number but positive. So here I am comparing 3 over 2 with half. Having the same denominator, then the one with the greatest numerator is going to be the greatest, which is 3 over 2. So absolute value of negative 3 over 2 is greater than half. Let's go now for number H. We said again that the absolute value of any positive number is the same number as it is. And here I have a mixed number, 7.5. How can I write 7.5 in a form of an improper fraction? Let my denominator be the same. Go and multiply 2 by 7 and I will have 14. And then add to it 1, it's 15. As you can see, the two rational numbers are equal. So absolute value of 15 over 2 is equals to 7.5. Let's go now for question number 3. Right beside question number 3, classwork. Which of the following rational number is greater? Here in this example, I have different numerators and different denominators. And we said to compare between two rational numbers having different numerators and different denominators, it's most easy to do cross multiplication. So I'm going to make cross multiplication. 3 times 4 is equals to 12. 7 times 2 is equal to 14. Sure, 14 is greater than 12. As a result, I will have 4 over 7 less than 2 over 3. Let's go now for number B. Again, I have different numerator and different denominator. So the easy way to solve this question is to do cross multiplication. 5 times 5, it's 25. 6 times 4, it's 24. 25 sure is greater than 24. So as a result, I will have 5 over 6 greater than 4 over 5. Let's go now for number C. Negative 7 over 6 or negative 11 over 15. Let's go and do cross multiplication again, since I have different numerator and different denominator. 15 times negative 7 is equals to negative 105. And 6 times negative 11 is equals to negative 66. As you can remember that when we are comparing negative numbers, the smallest number is the greatest. As a result, I will have negative 7 over 6 smaller than negative 11 over 5. And let's go now for number D and the last question in today's lesson. Negative 8 over 3 or negative 16 over 7. Which one of them is greatest? Let's go now and do cross multiplication, since I have different numerator and different denominator. 7 times negative 8 is equals to negative 56. And 3 times negative 16 is equals to negative 48. Negative 8 over 3 is less than negative 16 over 7. And by now we have finished today's lesson. Tomorrow we are going to complete the rest of lesson 2. I would like to thank you all, Prep 1, and have a nice day.